Hello friends, I welcome you in lecture number 14 on vector calculus. In this lecture we will discuss one more question on finding line integrals. The question is, find the work done in moving particle from point 101 to another point B 212 along the straight line AB in the force field F bar given by x square I plus x minus yj plus y plus zk. So as we know that if we consider a line integral of a vector function f bar along curve C or along any path C, then this line integral is work done by a vector function which is generally called a force field in moving one particle to another particle along given curve C. If we consider portion of curve between 2 points A and B, and if we want to find out the work done by force field F bar in moving a particle from point A along curve C to point B, then that work done is given by line integral of given force field F bar along that path C. So here we are asked to find out the work done in moving a particle from this point A to another point B along the straight line AB in the force field F bar. So here given curve is straight line AB. So we are not given the representation of curve, but it is given that curve C is the straight line joining points A and B, or the path of integration is the straight line joining 2 points. So first we write that the path of integration or curve along which we have to find out integral is the straight line. The path of integration, which we generally denote by C, is the straight line joining 2 points, and these 2 points are given in R3. So this straight line is a line in R3 or in space. Straight line joining points capital A and B. A has components 1, 0, 1 and B has components 2, 1, 2. So first we have to decide the parametric representation for this line AB. So as we know, if we have two vectors, say A bar and B bar, suppose I want to find out the representation of a line joining two vectors A bar and B bar, then first we find out the difference of A bar and B bar, then we multiply this difference by t, and plus we write down either vector A bar or B bar. Suppose we write A bar, and if we simplify this, we will get the parametric representation for the straight line joining these two vectors. So in our case, vectors are considered, we will consider position vectors of points A and B, and we will be able to decide the equation of straight line in R3 in parametric form. So first we write down the parametric representation for line AB. So the parametric representation of this straight line AB is given by R bar t equal to, we write any of these 2 points. Suppose we write this vector 1, 0, 1 plus t times difference of these two vectors, vector representing point B and vector representing point A. And after simplifying this, we will obtain the parametric representation of given straight line, which is our path of integration. So we now take the difference of these two, x component minus x component, 2 minus 1, 1 minus 0, that is 1, and 2 minus 1, which is also 1. And if we further simplify this, we have r bar t equal to 1 plus t and 0 plus t into 1, that is t, and again 1 plus t. If we wish, we can write one more step. This is as it is, and we multiply each of these component by t, and we will have this representation. Then we add these two vectors, 1 plus t, 0 plus t is t, 1 plus t. So this is the representation of straight line joining 2 points, and our straight line is between points 101 and 212. So we have to decide the value of t which will give us these 2 points. So if I want to decide the value of t for point 101, I will compare this vector 1 plus t comma t 1 plus t with point 101, and by equating these two vectors we will be able to decide the value of t. If we compare second components, we have t equal to 0, and we have to match with other equalities also. We must get the same value of t by comparing any of these three components. Suppose we compare first components or x components, we will have 1 plus t equal to 1, that will also give me t equal to 0. Similarly, if we compare last components, then also we obtain t equal to 0. So t equal to 0 is the point corresponding to first point A. Similarly, we decide the value of t corresponding to second component. So again we equate this vector, which is parametric representation, to another point, which is 2, 1, 2. So now we compare again these two vectors, and we find out which value of t corresponds to this point. So by comparing second components, we find that we obtain t equal to 1, but we should check for other components also, and we must get the same value if we compare any of these x, y or z components. Suppose I compare first components, then I will have 1 plus t equal to 2, that will also give me t equal to 1. Similarly, if we compare last components, we will obtain t equal to 1. So the value of t corresponding to another point B is t equal to 2. So in our parametric representation, the restriction on t will be from t equal to 0 to t equal to 2, and that will be our limit of integration once we convert our line integral in terms of t. And we can verify by taking t equal to 0 and 2 also. Suppose I put t equal to 0, I will obtain 1, 0, 1, that is my point A. Similarly, if I take t equal to 1, I will have 1 plus 1, that is 2, then t equal to 1, 2, 1, 2. So here I obtain 2, 1, 2, that is point B for t equal to 2. So this is correct parametric representation for the part of straight line joining 2 points A and B. Or if we restrict these values of t, then this parametric representation gives us the portion of the straight line or line segment joining points A and B, and that is our path of integration. And now we differentiate this with respect to t. We will require dr bar by dt also. So derivative of r bar with respect to t. Here derivative of 1 is 0, derivative of t is 1. Similarly, second component is t, its derivative is 1. Here derivative of 1 is 0 plus derivative of t, which is 1. So dr bar by dt will be this 1, 1, 1. And another thing we will require is we have to convert our vector function in terms of t. So in that vector function, we will put x equal to 1 plus t, y equal to t, and z equal to 1 plus t. So now we convert given vector function in terms of t. So first we write given vector function, it is x square I. Let me check another components, x square, x minus y and y plus z. X square I plus x minus y times j plus x minus y and y plus z, x square x minus y, y plus z. And here I have to put, let me use this same notation. Either we have to use this notation or we can use vector notation also. Now we put x equal to 1 plus t, y equal to t, and z equal to 1 plus t. Put x equal to 1 plus t, y equal to t, and z equal to 1 plus t. And let's see what our f bar will be. So f bar of r bar t, that is we are converting f bar in terms of t. So x square here, so that we write x equal to 1 plus t square I plus x minus y, that is 1 plus t minus t, x minus y. So let me use the simple bracket. X minus y, x is 1 plus t minus t j plus y plus z, y is t plus z is 1 plus t times k. And let's simplify this. This is 1 plus 2t plus t square, because we have to square 1 plus t. Here t will cancel out and we have 1 times j, and here we have t plus t, 2 times t, so we write 2t plus 1 times k. So our f bar is also converted in terms of t. So now we can write down the line integral, or first we write down that work done. We are asked to find out the work done by force. Here f bar represent the force field or force vector field. Force field f bar is, that work done will be equal to line integral of given force field f bar along straight line AB, and this is by the definition of line integral. Now we have converted f bar and r bar in terms of t. So here first we use the definition dr bar by dt, here dt, and we have to decide dot product of f bar of r bar t and dr bar by dt, and limits of integration will be limits of t, which we have decided as t equal to 0 to t equal to 2. So we write down that limits here. Now we first substitute values of f bar and dr bar by dt in terms of t. So f bar has components 1 plus 2t plus t square, so that I write in vector form 1 plus 2t plus t square. Second component is 1, third component is 2t plus 1. So 1 and 2t plus 1. Dot product with dr bar by dt. The vector dr bar by dt has all the components as 1. So that we write here 1, 1, 1, and after taking dot product we will integrate with respect to t. And dot product is easy, we have to multiply corresponding components and then take their addition. So 1 plus 2t plus t square into 1, that is 1 plus 2t plus t square. Similarly, second components are 1 into 1 is 1. Third component here is 2t plus 1, that is multiplied with 1. So we have 2t plus 1 integral with respect to t. So first we rewrite all these powers of t. Highest power is t square, then 2t plus 2t, that is 4t, and constant terms are 1 plus 1, 2 plus 1, that is 3. Now this is problem of single variable integration, definite integral of this function of only one variable. Integral of t square is t cube by 3. Integral of t is t square by 2, that will cancel 1, 2 here. So t square by 2, and that 2 in the denominator will cancel out with this 4, and we are left with 2t square. 3 into integration of dt is t, and limits of t are from 0 to 2. Finally, we put limits of t. Upper limit is t equal to 2. So if I put t equal to 2 here, I will have 2 raised to 3, that is 8 by 3 plus 2 into t square. T is 2, so t square will be 4, and I will have 2 into 4, that is 8, plus 3 into 2, that is 6, and lower limit is t equal to 0. So there is 0 contribution from lower limit because all the terms are containing t. And finally we can simplify this. This is 8 by 3 plus 14, and this I can further simplify by taking LCM. 14 into 3 is 42 divided by 3, and 42 plus 8, that is 50 divided by 3. This is the work done by force field F bar in moving a given particle from point A to point B, and we obtain this value. The work done by force field F bar in moving a particle from point A to point B is 50 divided by 3. So this is also problem of line integral, but the question is asked in another way. You have to find the work done in moving particle from point A to point B along the straight line in the force field. So remember that the work done by force field F bar in moving a particle from one point to another point is also line integral of vector function F bar along given path of integration. So remember, whenever they ask you this type of problems, then also you have to obtain line integral of given vector function along given path. If you are not given the equation of a curve, then first you have to decide the equation of a curve, or you have to write down the parametric representation for a given curve, and then you convert your given vector function f bar in terms of parameter t, and finally use this definition of line integral, and you will be able to decide the work done by a given force F bar in moving a particle from one point to another point. So this is all about this session. In this session we have discussed this question about work done, and this question was asked in GTU Summer 2020 exam. So I hope you like this lecture. Thanks for watching.